Hello. For this video, we'll dive into the fundamentals of implementing a linked list in Python. We'll start with the basics by creating a node class which represents each element in the list, and a linked list class to manage common list operations in the linked list as a essential structure used to organize and manipulate the data. We'll go through methods like add, remove, update nodes, as well as some special operations like reversing the list. So we're going to try to go first in the creation of a node to understand what a node is in a linked list. And then this way we can start thinking like how neural networks are created or evolved and so on. So first, this is typically the setup that you get on a let code question. So they provide you with a code with a node or uh, like a binode or like by tree, and either a linked list or a double list or a double linked list or so on, right? So what is this? So if you have a node becomes just this, right? One object. And these nodes typically have in a list, you're gonna have so in a list you're gonna have just objects, right? That you can access with an index. In a linked list, the memory is saved, and this is saved on like a slot of memory that is predetermined, right? Um, in a linked list, not necessarily the same spot, but you can change it, right? So in a linked list, you're gonna get within the data of your computer, these objects are just gonna get saved somewhere there. Like it doesn't matter where. So if you have two objects, they're gonna be linked together somehow, which cannot happen on this. You cannot have that because you have indexes, right? So you have to go through indexes. So these will have to appear, it cannot go there. But in a linked list, they're saved anywhere in the list. So you're basically just following that pattern. And then typically you have in the node, this is a node. You're gonna have a single node, you're gonna have your value, and you're gonna have like a little tail, right? And this tail is typically none. If you start thinking about these objects for machine learning purposes, you can start thinking like double linked lists, right? So this object is linked twice, or so on, right? You can start looking into these objects in different ways, and then you can start thinking about matrices. The none can become a weight, uh, and so on. But this is what we're creating here first. And then for a linked list, we're going to start thinking about how these objects work linked together, right? Because if this object is linked to this, then this is not none anymore. This will become this value, this will become this value, and this will have its own node value, right? So we start looking into next, the value. This is the head, this will be the tail, right? So if this is the head, this is the tail of my list, and so on. So how can we represent this node? How we start a class node? So first we're gonna pass the self, because how you define it is your node is gonna be defined with init, and it's gonna be self. So you're always gonna pass the self and a random value. So the value is decided by whoever is using the class. So then you have the value, because every node needs a value, and every node needs a next. And the next is that little tail for each individual node. And we're always gonna initialize it as none, right? So this is right here, we just created a class that allows you for the creation of these. So if you use this class and you node and you pass a value, let's say 4, now your node becomes 4 in the center, right? So then that's your node. So you have your none and your node. So we here, if we use these, that's what we're creating. So how do you create a linked list from here, right? You need to give maybe more values, or you can append values, but you can create a list of one object as well. So let's create a linked list of one object so we understand it. So first we're gonna need a new node, because for the linked list we're gonna need at least a single node. Then we're gonna pass our class that we just created, node, and then we're gonna pass a value, which is gonna be the same value that we're passing here. So to create the linked list, we know that we need to pass a value, so that's the value that we're creating our node with. And then the linked list is always gonna have a head, which is gonna be the value of the new node, and a tail, self.tail, which is the value of the new node. And then we're gonna keep track of the length 1. So every time we create this, we're creating a length of 1, we're creating a tail and a head for our linked list. So how does this look after we run this code, right? We're gonna have our element. So if we, in this line, before we print, we called our linked list. So we call our linked list method or class, and then we add a value, right? Then this is creating our value, and then this becomes the head, and then we create another tag called the tail. This whole thing is equal to 1, and then we also have our tail, because it's a node, we created a node, and the next is none. So this is what we created, right? So if we want to access the value, we do that value, and it will give us 4. If we want to access the head, is head, and that will give us 4. Tail right now gives us 4 as well, and so on. So if we have multiple of these objects, let's say one more here, this doesn't become none. Let's say this one's 3, then this becomes 3 because it's the next object. So we're basically calling this. So you're not thinking about this as weights, but now we're calling the next object, right? And then our tail would automatically become this, because now the head of the two objects is 4, and the tail of the two objects will become this 3 inside. Right? There. So that's more or less how it works. So now we created our thing, and now we're not going to do reverse right now, but now we're going to print it. So how do we print this? So we cannot just print this list, right? So let's say we want to create this list. So let's call list is going to be equal, right? If we want to print this, okay, let's do it in a minute. So list is going to be equal to linked list, and then we're going to pass a value. Let's say value of 4, and then let's print list. So that gives us an object, right? But we don't want to see the object. So this is a node, and it's saved somewhere here, right, in your computer. We want to print the value, but we cannot do list length that value because that doesn't give us a value. We cannot do head to our list because it gives us the node. So we need to access the value. How do we access the value? We need to iterate through our list to get that value. So how do we do that? First, we need to create like a temp object, right? So temp that equal to self that head. So what are we doing here? And this is important because if we want to start thinking about iterating through multiple linked lists or double lists, we need to understand how this works. So right now, if we had, let's say, a double linked list, this is our tail, this is our head, these are our values, this is the next object, and this one is none, right? Because this is the element of this. So this one doesn't have any object, so it's not. Okay, so we're creating a temp object that is the head. So now we have another temp object, right? That is also the value of the head. So in reality, we're doing this. We're copying this value here, right? So if we change this value, h, the head, it wouldn't change this value anymore. So then we can start thinking about, okay, how can I move around one value on the linked list without losing the link to create that communication and manipulation of the list, right? So then let's say we have the head of this, and then we're gonna create a loop through the full temp object, right? Because we're gonna print the full loop of the temp object. So this basically is while temp is not none. So if my list, my next item is not none, so it will go 1, 2, 3, and so on, right? So while temp is not none, then print temp.value. This is how we access the value, because now we're within this and we can call this class within our linked list. So print that value, and then temp, we need to update temp so it moves to the next object. So temp.next. So here we're first printing the value, right? First we're printing the value of this object or this node, and then on this line we are moving to the next object on the list, and then the list loops back while, and then it starts over, prints this value, and then it updates to the next. And if it's none, then it prints none, right? If we want to, if we just want to print the value, then we call the class or the method to the class itself. So how do we call a method to the class itself? So it's two different ways, right? If we update this, we print list, we have our head. But if we print, let's say just the list, but if we call our method, so we have our list, and then we're calling our method within that list, and then we can print it, it prints the value, you see? So this is like a good exercise to start thinking about linked list, how nodes work, and then you can start using this to manipulate double linked lists or data trees and different type of matrices and so on. So this is the first video, but we're gonna go over like all multiple different methods that give you the opportunity to append, pop, prepend, get self values, or insert, and an important one that is reverse. That it comes on different um, interview questions at times, depending on the level. But reverse a linked list is like a catch question. So yeah, I hope this helped, and I'll keep making the rest videos soon and uploading. I hope they help. Thank you. Bye.